Okay, so could someone rephrase what this is talking about with dividing by 0? Yes, Sydney.
Basically, they're saying that dividing by 0 makes no mathematical sense to get an answer, because you can't take a number and then divide it by 0, because technically you're taking it and separating it into 0 groups. But giving the answer 0 to a number divided by 0 doesn't work either, because if the answer is 0, then you have 0 groups. Then you have 0 groups of 0 numbers, and it just makes absolutely no sense.
I agree. Does everyone agree with that? Yes. I completely agree. Like what she's saying is, when you divide 12 by 3, it equals 4. So therefore, 4 times 3 equals 12. If you divide 6 by 0 and it equals 0, well, 0 times 0 does not equal 6. So we agree 6 divided by 0 is not 0, it's undefined. Perfect. What about with reducing fractions? What did you say? It's easy? Yeah, it is.
Yeah.
What is the first step? Factor. Finding GCFs and factoring. Good. Let's do 1 and 3 together. What were the factors on top for 1?
X minus 1 and
X minus 1 and x plus 5? Okay. And then the bottom? So what reduced to 1? Yeah, so it reduced to x plus 5 over x plus 1. Okay, what about the bottom? Sorry.
excluded values.
Oh, thank you. X cannot equal.
Yeah. Negative 1 and 1.
Perfect.
Good catch. Love that.
Yes. Okay. Number 3. What do those two factors look like? On the top. Did someone say my favorite thing?
Yes.
What'd you say?
GCF.
GCF. What was the GCF?
Yeah, 9x times x.
Perfect. And then what were the factors on the bottom?
7x minus 1 times x minus 3.
Awesome. So this reduced to? Yep. And what were the excluded values?
Negative 3 and 1 over 7.
Very close.
Oh wait, 3.
3. And then 1 over 7. Good. All right, so today we're going to do what we've been doing last time, but add something. I will show you what. So let's look at this graph. Could someone tell me what was the g of x for negative 4 for this graph? Go ahead and look at it. What do you find for g of x? 0. Good. What about g of negative 1?
Negative 46.
G of negative 1?
That's what my calculator said.
Did you do the x squared plus 2x minus 8 over?
It's error.
Over x squared minus x minus 2.
Uh-huh.
Trace. And I plugged in negative 1, and it said negative 46.
Hmm.
Yeah.
I'm hearing error. What is the vocab word for error?
Because it's the excluded value.
Undefined? Oh, because it's the what?
Excluded value.
Oh, negative 1 is an excluded value.
Asymptote.
Or an asymptote. Okay, cool. 0. Someone raise your hand. What did you get for g of 0? I hear people saying it. Yes. 4. Right here, go to your graph at 0. You go up and it hits that 4 right there. Okay. Okay, what about g of 2?
2.
I'm going to put a little question mark there. And then g of 5. Yeah, 1.5. All right. So I want you guys to think about this really quick. I see that you guys said 2 for 2, but what do you notice at the 2?
And the dot.
There's a circle, open circle. Okay, so we're gonna notice that.
So it's not that. Because an open circle means it's not.
Not that. Good. So let's think about this. How many excluded values do you think that denominator is gonna have?
2.
2, right? Because it's a quadratic.
Yeah.
What are the excluded values?
-1 and 2.
-1 and 2. Okay, x cannot equal -1 and 2. But last time we learned that excluded values meant vertical asymptotes, didn't we?
Yeah.
Kind of, right? We talked about it 2 ways. We called it a discontinuity, right?
Yeah.
In the homework, it was a discontinuity. And then we said we find our vertical asymptotes from the excluded values. Both true. However, that would mean this should have a dotted line right here, right? Yeah. Well, there's a dotted line at -1, so that makes sense. But this is not an asymptote. It's a whole. Good. Okay, so I want us to look at this equation. X squared plus 2x minus 8 over x squared minus x minus 2. Can we reduce that fraction, do you think? What would we do to figure out if we could reduce this fraction? Factor. Okay, what are the factors of the top?
X minus 2 and x plus 4 over x minus 2 and x plus 1.
Is anyone catching on so far?
Just cross them out.
Okay, we could just cross them out. So what happened to this excluded value?
It's still
It almost disappeared? Right. Exactly. This excluded value was removed, right?
because it's shared with the top and bottom.
Huh?
Because it's shared with the top and bottom.
Because it's shared at the top and bottom. Was this value removed? This excluded value removed?
No.
No. Okay, think about that. Okay. Think about how this one was removed. This one wasn't. This one was a vertical asymptote, but this one was a whole. Can somebody on your graph, actually I'm just going to do it right here. I'm going to graph the equation x plus 4 over x plus 1, right? Because we agree if this was reduced, it would look like that. Yes?
Yes.
Okay. So if you want to follow along on your calculators, graph x plus 4 over x plus 1.
It's the same as the first one.
Oh, it looks exactly like this graph, right? I don't know if you could see that. It crosses at the y-intercept 2. There's an x-intercept at -4. And it looks like the asymptote is at -1, x equals -1, right? Okay, it looks the same.
Except
Except,
on the second graph, there is no hole at 2.
exactly, in the second graph there's no hole at 2. Okay, so this is what's happening. This excluded value matters in this equation, but only at x equals 2, at the point x equals 2. Everywhere else is exactly like the other equation, okay? So what we call this is a removable discontinuity. So if you can cancel it, or not cancel it, reduce it and take it away, then it's a removable discontinuity, and on your graph it looks like a hole. Does that make sense? Is anyone lost and have a question? We good? Good.
What's the domain then?
What's the domain?
So is it gonna be like negative infinity 1, 1 to negative 1? Like negative infinity to negative 1, sorry. And then negative 1 to 1. I mean 2. And 2 to infinity.
That's exactly right.
Oh.
Because x can't equal what?
Wait, so.
Negative 1 and 2. So that's your domain. Good.
Yeah.
Because 2 is like like an asymptote.
Kind of like an asymptote, but not quite. It's called a discontinuity.
Change the direction.
That'll be your word for
so
it.
you
Because
have
it's
to
an
change,
excluded value.
after the 2, you have to change the domain.
Yes. Because of that 2, it can't equal it. X cannot equal 2. So this domain tells me that x can equal anything from infinity until negative 1. Doesn't equal negative 1. But it equals anything between negative 1 and 2. Doesn't equal 2. Equals everything from 2 to infinity.
And if it has that circle, that makes it that discontinuity.
That hole right there is a removable discontinuity. Okay, so remember how we talked about asymptotes? What was the word we used for asymptotes? Like, what are they on a graph?
They're excluded values.
You can find them with the excluded value.
What is it called, the vertical, what is it?
There's a vertical asymptote. What are asymptotes, though? She referred to them as discontinuities, as like spanks.
Oh, like the shape thing.
Ah.
She said.
Yes.
You remember. Yeah.
It's
And you
not
laugh, but you
sus.
remember.
It's there.
It's shapewear.
Yeah, they shape you. Yes.
Okay, so if you're saying g of x, or g of 2 is equal to 0, or would it be equal to 2?
It's undefined.
So it's undefined?
Yep, this is undefined. If I plugged 2 into my equation, I would get a 0 error. So it would be undefined. You're exactly right. That is not equal to 2. It's undefined. But everything from 2 down and 2 up looks exactly the same on the graph. Okay?
So why is it undefined and not 0? Or, yeah.
Because if we divide by 0,
Oh, it's a divide by 0 error.
it's a divide by 0 error. Your excluded values give you a divide by 0 error. Right? Okay, so what I was going to say is your asymptote, the x plus 1, so your excluded value, which was negative 1, it shaped the graph, right? Because we can't remove it. It's non-removable. Can't remove it, so that means it affects the graph. Do you agree it affected this graph and this graph? Yeah. It affected both of them because you couldn't remove it, right? So your non-removable discontinuities are your vertical asymptotes because they shape the graph. They affect your graph, okay? If we look at, if you need a little extra help, if you're still like unsure about the removable one, the hole, what is 6 divided by 2? 3, okay? What is 18 divided by 6? 3. Are these the same numbers? Can I rewrite 18 divided by 6 as 6 times 3 divided by 2 times 3? Yes, right? So I could reduce that and just do this. So did that 3 over 3 affect what my outcome was? No. Exactly. So just like here, this x minus 2 over x minus 2 doesn't affect my outcome anywhere except for, where does that x minus 2 matter? At the hole, which was, what was the x value at the hole?
Undefined.
X value.
Oh, 2.
2, exactly. So this doesn't affect my graph anywhere except for at the 2. So we have to put a hole, but it doesn't shape the graph. Are we all good? Thumbs up? I'm loving the attention, guys.
So it's like the whole just skipping over that one tiny piece of the graph.
Yes, the hole is just skipping that one tiny piece. Yes.
Okay, so if you factor it and it shares a factor in the numerator and denominator, then it doesn't have, so then it's a whole.
It's a hole. Exactly.
That's important enough. I would have someone else in class repeat it, and then maybe even a third. Because that's
Wait,
the whole point of all
what
this.
Caden said, or?
What Caden just said.
Okay, can someone repeat what Caden said? Huh?
That was the person before Caden, but that's all right.
Hi, Chloe. I got it right. Okay, someone repeat what Caden said.
Something about a hole in the graph.
Something about a hole in the graph. Okay,
I think any of you were listening and
should we have
told you how
Caden?
to do it.
Should we have Caden repeat it?
It's up to you.
Repeat what you said. Hopefully everyone's listening this time.
Alright. If you factor it and they share a factor in the numerator and denominator, it's a whole.
Yes, someone repeat that. Yes.
If you factor in the numerator and denominator, it comes to a whole.
Yes. One more person.
Nate's got it.
Someone not from this table or this table. Back table.
Alright, if you factor it and it's on the numerator or the denominator, then it's a whole.
Yes. Amen. Let's put this all together. Let's go to number 9.
But that's the whole point, right?
Number 9 is
Actually, I don't want to do number 9. I actually want to go to page 20. Important notes on holes. Okay. I want you guys to compare your equations to the graphs.
Wait. So with number 9, I was just looking at it.
Yeah, go
Since
ahead.
you could cross both of those out, wouldn't it just be x plus 3 so it's a linear graph? Or is that not right?
No, you're exactly right. It's a linear graph except for
Two holes.
Yeah, the
one hole.
whatever it's called,
Except for one hole. Exactly.
at negative 3.
Okay, so what he said, this would be a linear graph that looks like this. Except for at 3,
You just
there would be a hole. Okay, so let's move on to page 20. I want you guys to look at the equations, answer the questions, and look at the graph to help you answer those questions, okay?